Alright guys, so I'm going to take just a couple minutes to go over the last question. I think it was question number 6 from the celebration about the two restaurants, Center and New. Alright, so let's go ahead and look at the problem. F is the event the customer chooses a fish roll, S is choosing a salad, and N is neither a fish roll nor a salad. Alright, so if we look at this in a Venn diagram, we don't know anything about it. We don't know if it's independent, dependent, mutually exclusive. And so we draw it in this way knowing that this will cover all of those situations, and it may just be that the overlap is 0 if it's exclusive. So we can go ahead and draw it. We've got the fish, we've got the salad, and then from there we've got the neither, which is outside of that. Okay, now it gives us information about PF. The probability of F is 0.31 and the probability of the salad being 0.62. Then it says neither is 0.14. Now neither is everything outside, which means that that's exactly the opposite of everything inside. Now everything inside can be written this way, probability of F or S, right? So therefore the probability of F or S is 1 minus whatever's outside, 1 minus 0.14, which is 0.86. Most people got that part. Now from here, to show that F and S equals 0.07, the best way to do that is using the law of probability to say the probability of FUS equals the probability of F plus the probability of S minus the probability of F and S. Now, you really should write this out. A lot of you just kind of wrote numbers down and you kept writing numbers down until you got to 0.07. It's very difficult for them to know if you did that because you knew what was going on or because you just kept moving numbers around until you got 0.07. And they may or may not give you all of the points for that. And so when it says show that, you need to use mathematically valid processes to show and demonstrate the fact that that's the case. So here you would go probability of F or S, so that's 0.86, equals probability of F, which would be 0.31, plus 0.62, minus the probability of F and S. And so from there you would subtract the 0.31, subtract the 0.62, and you would find out that that would give you negative 0.07, divide by the negative, and you get the correct answer. So you end up getting negative 0.07 equals negative probability of F and S, which then means that, of course, that has been shown. Now, because it's a show that, you can almost guarantee that this information needs to be used in the next part. If you don't, then you're probably doing it either the hard way or the long way. All right, now what this says is given that the customer chooses a salad, find the probability that they choose a fish roll. Or in other words, find the probability of a fish roll given that they already had a salad. Now we've got an equation for that. Again, one of the laws of probability states that we can get that by going the probability of F and S divided by the probability of S. Pay attention to the letters. Some of you did something strange. Oh, wow. What just? Oh, there one. Okay. Some of you did something strange with the letters, and you ended up having probability of F on the bottom. Pay attention to what's here, what's there, how that affects what goes into these slots, the A, the B. Make sure of that, because this should have just been 0.07 divided by the probability of a salad, which is 0.62. And when you do that, you should then end up with 0.07 divided by 0.62, and we got 0.113. Very good. There we go. Now, what we're going to do is let's go ahead and look at part C. All right. So, part C, are F and S independent events? Well, there's several ways to go about this. The easiest one is to say, well, if the probability of getting fish if you get a salad is 0.113, and the probability of getting fish is 0.31, then no, they're not independent. Obviously, the probability of getting fish depends on whether you got a salad or not. It changes. So that's one way to do it. The way that a lot of people did it is they just said, okay, well, PF times PS and they found out if that ended up giving probability of f and s, which it didn't. Okay, so either one of those reasonings should work fine then. Okay, so now we're on to letter D. At new restaurant, PN equals 0.14. Twice as many customers choose a salad as choose a fish roll. Choosing a fish roll is independent of choosing a salad. This is a different restaurant. You may not use the numbers from center restaurant to describe new restaurant. Okay, these numbers all apply to center. You may not use those numbers again. If you use those numbers, you get 0 points. Okay, so we're going to totally ignore everything that just happened because it's not helpful here. We're going to look specifically at the information we have. So we've got that the probability of not getting anything is 0.14, which means that the probability of getting fish or salad is again 0.86, right? Because again, you've got your fish and your salad, and nothing is outside, so therefore if that is 0.14, then the stuff inside is 0.86. It says twice as many customers choose salad as fish. So if I've got fish and I've got salad, right, it says twice as many choose salad as fish. So that means however many fish there are, twice as many people get salads. It has to be with the 2 in front of the PF. Now, many of you got away with putting the 2 in front of the PS, but that doesn't make sense. Twice as many customers choose a salad. Think about that. So just put a number with it, right? If fish rolls is 5, read that. Twice as many people got salad as fish rolls. So how many people got salad? Twice as many. So 10. So if salad is 10, then that is fish times 2. So it's got to be this. It's not PF equals 2PS, which is what a lot of you got away with. Choosing a fish roll is independent of choosing a salad. So I've used this information. I wrote that down. Now I need to write down that choosing a fish roll is independent. Well, the only thing I know with independent is that when it's independent, that PF times PS equals PF and S. So I'm pretty sure I'm going to use that, because otherwise, why would they have given me independent? If they give you information, you're going to use it. Every single piece I've now written down. Now I see something with F and S, I see something with F or S. That clues me off that I'm going to be using PFUS equals P of F plus P of S minus P of F and S. Now, the question is asking, find the probability that a fish roll is chosen. So I am looking for P of F. What I'm going to do then is I'm going to make that X. P of F is going to be X. So anywhere I see P of X, that's going to be X. I'm going to fill in whatever I can. So the probability of F or S, well, that was right here. So that's 0.86 equals, there's the probability of fish roll, so that's X. Now here's the probability of a salad, but we know that probability of salad is 2 times PF. And PF is X. So that's 2X. And then I've got minus P of F and S. Now F and S is PF times PS. So then I go X times, and what was PS? PS was 2X. So X times 2X, which then is 2X squared for P of F and X. So then I go minus 2X squared. Now at this point, this is on the calculator section, so I could just graph it here. I could just go 0.86 there, X plus 2X minus 2X squared, put that in for Y2, and graph it and solve. If you want to do it a little bit more difficult, if you are a glutton for punishment, whatever, you could go ahead and make this 3X. You could go 0.86. You could then move everything over, so you have 2X squared minus 3X equals, plus 0.86 equals 0. Now you're going to say, oh my gosh, I can't do this anyway. I got to use the quadratic formula. And if you're going to use the quadratic formula where you're square rooting things with decimals, you may as well just put the dang thing in your calculator. So I'll go ahead and put it in the way it is now. So I'll go 2x squared minus 3x plus 0.86. Yep, I see that the 8 and the 6 didn't show up, and neither did the 3. So I got to go back over there and insert the 3. Okay, there we go. 2x squared minus 3x plus 8, 6. And then I'm going to go ahead and graph it. And hopefully I got a graph. There's my graph. I'm looking for the place where it's equal to 0. So maybe I zoom in a little bit. Let's go zoom decimal. There we go. I can see it a little bit better now. So I'm going to go second calc. I need the 0. Now there's 2 of them there. But note that this second one is bigger than 1, right? That doesn't make sense. It can't be bigger than 1. This is a probability, for heaven's sakes. So I just want the one over here. So I go left bound, I go right bound, and then I push enter, and it gives me 0.386 essentially, which is then the probability. That's x, which is, of course, the probability of the fish roll. So there you go. That's question number 6 and the last question. Note that even with all of my talking, it took me 11 minutes to do that. Okay, it's a 16-point question. You get 16 minutes. So if you really know what's going on and you know that every piece of information you're given is going to be used, you should be able to finish even these long questions in significantly less time. That should then allow you to have more time on the harder questions. All right, so there you go, and I hope that's helpful.